Today we're going to find the value of the 6 different trig functions when we are given a certain point. So let's say that we're given a point 3, 7. Okay, think about that on the coordinate plane. Okay, so 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Okay, think about it on this coordinate plane. If we go over 3 and up 7, there's our point. Now, if you extend this thought to a triangle, you can extend it down and then also to the origin. Now the distance from here to here was 3, and the distance from here to here was 7, right? The y value is 7. So now we have a right triangle with one side length 3 and one side length 7. Now we need to find this length here, right? We can do that by using the Pythagorean theorem because it's a right triangle. So we can have a squared plus b squared equals c squared. Here, we can think about that as x squared plus y squared equals r squared, because that is our radius here in terms of trig functions. So our x value was 3, so we have 3 squared. Y value was 7, so that's plus 7 squared equals r squared. Now 3 squared is 9, 3 times 3 is 9, plus 7 squared, 7 times 7 is 49, and that still equals r squared. 9 plus 49 is 58. That still equals r squared. Now we're looking for r here. We have r squared, but we need r. So to do that, we need to take the square root of both sides. And when we do that, we're left with square root of 58. Square root of 58 cannot simplify down any further, so we're left with just square root of 58 equals r, because r times r is r squared, and the square root of r squared is r. So now we know what r is. R is square root of 58. Now we need to find our 6 trig functions. Okay, we have the 3 parts that we need. We just need to find the 6 trig functions. Now our 6 trig functions, our first one is sine of theta. Sine of theta, by definition, is y over r. Okay, you can also think about it on the is y over r. So our y value was 7 and our r value was square root of 58. Now we can't leave it like that because you're not allowed to have radicals, the square root, in the denominator. So to clear that, we need to multiply the top and bottom by square root of 58. And what we're left with is 7 times the square root of 58 over 58. Okay, the 7 and the 58 can't simplify down any further, so this is our answer for sine of theta. Our next trig function is cosine of theta, and that is x over r. Our x value over here was 3, so 3 over, then our r value was square root of 58. Same thing as up here. We can't have the radical in the denominator, so we multiply top and bottom by square root of 58. This gives us cosine of theta equals 3 square root 58 over 58. Okay, again, the 3 and the 58 cannot simplify down any further, so this is our final answer. Next was tangent of theta. Tangent of theta is y over x. Now our y value was 7, and our x value was 3. So this is our tangent value here. Tangent of theta is 7 over 3. Okay, so that equals tangent of theta. Next up was cosecant of theta. Now cosecant was defined as r over y, because cosecant is the reciprocal of sine theta. So y over r, our r value was square root of 58, and our y value was 7. And notice here, we don't have a radical in the denominator, we just have the 7. And these can't simplify down any further, so that is our final answer. Okay. Now let me next was secant of theta. Secant of theta is the reciprocal of cosine, and that is r over x. Okay, our r value was square root of 58, and our y value, or our x value is 3. Again, this cannot simplify down any further, so this is our answer. That is secant of theta with these values. Our final trig function is cotangent of theta. Now, this is the reciprocal of tangent. Notice we had the reciprocal of sine, the reciprocal of cosine, and now we have the reciprocal of tangent. And that is x over y. Our x value was 3. Our y value was 7. So cotangent, this cannot simplify down any further, so the value 3 over 7 is your answer for cotangent of theta with these values.